All right, so in the last video, we stopped off at the Stroop task. Now, in talking about selective attention and thinking about top-down, bottom-up processing and this idea of early and late selection models, the Stroop task was a really good tool that experimenters could use to look at how meaning can actually get in the way of these really simplistic interpretations of stimuli. When I say Stroop, I don't mean Stroop waffles, I mean the Stroop task, in which we can demonstrate that the name of a word can interfere with the ability to name the color of that word. Basically, we can't avoid paying attention to meaning, as opposed to just the physical characteristics that Broadbent talked about in his filter model. Now, participants would be shown for a control circumstance, series of shapes of different colors. Now, the thing about this is that we don't necessarily have an inherent color meaning to shapes. A circle is a circle, a square is a square. We don't have very strong associations with color and shape. But if I show you the color red and the word red in the color red, and the word yellow in the color yellow, you'll probably say the color of the word just as quickly as if you were going to read the word. Now, we run into a problem when I ask you to name the color of this word as opposed to the word itself. And you can actually demonstrate this for yourself. Basically, just going through a series. These slides will be posted. If you go through the series of these slides and kind of test yourself to see how quickly you can state what color is being presented, then you'll see that you're a lot faster when there is some congruence between the color and the word. Here's another example of that. It looks strange just to look at this example because we can see the word yellow, but we know it's in blue. And so that Stroop effect has been demonstrated in other areas, but the one that's the most commonly used example is the color and word meaning example. Now, how we control our attention is a really important component in looking at what we do to actually strategically apply cognitive resources. And one way to do this is to study overt attention. And we do this through the use of eye trackers. And there are several different ways that we look at the movement of the eyes to measure behavior. One thing that the eyes do that's almost subconscious is a thing called a saccade, and this is a rapid eye movement. The GIF that I have here, those very tiny micro movements that the eye is making basically to rapidly scan a scene is what's called a saccade. Fixations are typically what we use to look at how long someone is attending to certain areas of a screen or of a any sort of scene that might be shown as a stimulus. And basically we get a person to sit, look at a computer screen oftentimes, and then ask them to either answer questions or scan the scene, and then we see where their eyes fixate to determine what parts of the scenes are the most salient. Now, this bottom-up eye movement that's occurring at this really basic behavioral level depends very much on the stimulus. So the idea that if I give you a very rich scene that has a lot of information in it, your eyes are going to move differently than if I give you a scene that's very bare. And also if there's movement in the scene. And basically what your eyes are going to do is they're going to focus on highly salient stimuli. Salience is basically the importance of information in a scene. And evolutionarily, movement and color are very important and highly salient features in an environment. Movement might indicate predator or prey, moving towards or away if we were hunting. And color is also a very salient indication of often gathering, and rapid changes in color can also be indication of danger or some sort of basically bad situation. Top-down eye movements, however, those happen after our bottom-up processing has occurred, and these are often determined by the task. If I give you some sort of prompt to prime you to think about a scene before you see it, there's a good chance that top-down eye movements are going to take over and then influence where your eyes go in the scene, basically to search for meaning, to reconcile that prompt that I've given you. And an example of something like this is in experiments where you ask participants to make a peanut butter and jelly sandwich. And in this case, you can show them this picture and their fixations will move almost in the same order that a person would take to actually prepare a peanut butter and jelly sandwich. You can see those fixation points on there. These two GIFs are also examples of other sorts of eye tracking applications, looking at how people focus in virtual reality, and also just using different computer programming to actually track the iris during eye tracking experiments. Now, one thing that we can demonstrate in a lot of these eye tracking experiments is how we shift our attention without moving our eyes. And one of these things that we can do to look at this is something called pre-cueing. And this is that top-down component to basically giving someone an expectation, biasing where they're going to focus their attention. And what happens is oftentimes participants, when if I tell them that a cue is going to appear on the left side of the screen, without even moving their eyes, they will indicate that they attend or they see a object appearing on the left side of the screen much faster than an object appearing on the right side of the screen. And this is even when the eyes are kept fixed and straight on a focus cross. And here's an example of that. You see a cue, and that cue is indicating which side of the screen the target is going to appear on. And this is a valid trial. Basically, this is something where the arrow is accurate in indicating where the target will appear. An invalid trial is one in which the arrow points the opposite direction. So my expectation is that the target will appear on the left. Unfortunately, the target appears on the right. We can look at the speed, the reaction time at which people indicate that they see the target. And it's significantly higher in the valid, or it's lower but faster. Sorry, these graphs are always weird. They take less time in the valid conditions to react to the target than they do in the invalid conditions. And remember, their eyes are on this focus cross at all times. So there's not necessarily any eye movement influencing how quickly they can respond to one target or the other. Now, we look at these really simplistic components to eye movement and attention to start thinking about how we can divide attention. Now, dividing attention is something that's somewhat controversial, but if you think about opportunities that you have to divide your attention, if you think about it in terms of the processing capacity model that I talked about in the last video, there will never be a point where you are as good doing two things if you only do one of those things at a time. That's kind of the thing to remember as far as divided attention is concerned regarding these theories that I'm talking about from the book, is that there will never be a point at which you can accomplish reading a book and listening to music. You can never read that book as well while you're listening to music as you would if you were just reading the book. And that's something that's important to consider. And Schneider and Schifrin decided to look at really basic components to divided attention and how they could get participants to basically try and do two things at the same time. Now, basically, they were presented with a target stimulus. In this case, it was the number 3. And then they're presented a series of 20 test frames, very fast, fraction of a second fast. And some of them are distractors, and some of them actually contain the target stimulus. And then they're asked, was the target from the memory set present in the frame? And what we can see is that the more trials that and an important thing to remember is that the divided attention component to this is trying to remember the target and rapidly being presented stimuli. So those are your two things that you're trying to do. You're trying to remember something, and you're trying to analyze stimuli. And basically what they found was that the more trials that participants went through, the better they got. So basically more practice means that you can use fewer or less of your processing capacity, fewer cognitive resources in order to accomplish the task of remembering something and tracking stimuli. Now, an important thing to remember is that a lot of these processes, these strategies that we compensate for through practice, are automatic. So the example that I will bring up again and again and again is the fact how much we divide our attention when we drive a car. There are oftentimes a lot of different things going on. We're looking at the speed, we're looking at our radio, we're listening to our radio, we might be talking to a person in the passenger seat, we might be paying attention to something outside, we might be thinking about what we're going to cook for dinner. There are a lot of different things going on, and the process of driving is automatic, and the more you practice that, the more automatic it becomes. Now, the problem is that when we set on these automatic processes is that subtle changes are often missed because this process is being automated, and it's really difficult to notice subtle changes that are occurring. And this is called inattentional blindness. Basically, when a change in a scene is not perceived, even though you might be looking directly at it. For example, so this is an example of that inattentional blindness experiment. The fact that over a period of 1 to 5 trials, this green line actually gets larger. And as it gets larger, the 6th trial, a gray box appears. And then experimenters asked participants what changed about the scene throughout the trials. And a significant number of participants only said that the gray box was what changed. And so that's a really simple demonstration of inattentional blindness. And I have another example right here.
This is an awareness
I
test.
want you...
How many passes does the team in white make?
So look at the white team. So only the white team. The white team is passing the basket. Ball. Think about the number of passes that just occurred.
The answer is 13.
It was
But
13.
did you see the moonwalking
But did you
bear?
see the moonwalking bear? Now, don't even pay attention to the passing ball. Look for anything odd in the video. So this is a really simple demonstration of inattentional. That's actually an ad done by a government organization talking about inattentional blindness and basically how you can be looking at something and not notice it. There's a really interesting phenomena that oftentimes we are distracted thinking about something else, looking at something else so intently that we miss completely what would otherwise be salient cues or be not distracted. And thinking about attention in a more naturalistic way and thinking about the fact that we can demonstrate inattentional blindness using a commercial is really important because oftentimes we overestimate our ability to function and divide our attention appropriately. And so Schrader and Johnson did a 100-car naturalistic driving study basically to show that during a simulated driving task, participants that were on their cell phone missed twice as many red lights and took longer to apply the brakes than those participants that weren't. The thing is that regardless of what type of cell phone they were using, whether it be hands-free or they were holding it up against their heads, there was no change. So there's a cognitive component to this. Essentially, talking on the phone, having a conversation requires cognitive resources. That means that those cognitive resources that would otherwise be applied to driving are not being applied to driving. So it's a really important thing to remember. I don't have the citation here, but a more recent study looking at texting and driving demonstrated that texting and driving drivers function slightly better than inebriated drivers. Basically, that the cognitive resources that have been diminished due to drinking are basically equivalent to the amount of cognitive resources that you need to text and drive. Hence, a lot of different policies that have come out more recently, and more conversations concerning distracted driving and the importance of not dividing your attention. And just to reiterate, because at the end of the day, when you divide your attention, you'll never do as well if you just focus on one thing at a time. Okay, so thinking about how we divide this attention based on stimuli. So the book focuses on two components, those being location-based and object-based attention. The idea that I can scan a scene is location-based, and the idea that I can focus on different components of an object is object-based attention. And Egley et al. In 94, they asked them to look at two rectangles, so empty rectangles, basically they looked at those two rectangles, and then they were shown a target cue. And they were the fastest to respond when the target appeared where they told them. So remember that example I gave before with the arrow pointing to either the right or the left, and then the target appearing on the right or the left. But timing in between, so those invalid and valid cues occurred, but there was also an effect of those rectangles. So if the target appeared in the same rectangle in two conjoining stimuli, then reaction time was faster than if they didn't appear in the same rectangle. The idea that the feature of that rectangle changed, I was much less likely to notice that target is appearing in a different place, as opposed to having to switch to a different object, meaning the different rectangle. And so basically, this was a demonstration of how those two objects, the rectangles, can be influenced by the environment. So a static scene with a lot of changes occurring over a period of time might be an indication of a shift in attention, and a specific object that is moving or doing something is also something that will draw our attention when we are focusing on objects. Now, another really interesting cognitive phenomena is something called change blindness. And this is similar to inattentional blindness. And the idea is that over a long period of time, or sometimes over a short period of time, non-salient information tends to just get washed out. And so we can actually do some really interesting things in showing stimuli to participants. In this example, we have a conversation going on. The camera shifts 2 times, and then we come back to the conversation. And what researchers found is that participants remembered the content of the conversation, but they didn't remember the changes occurring between those two immediate scenes, the change in the color of the plates, the removal of, or the addition and then removal of the scarf between A and C, and then also the change in cup placement, and just a lot of little features that aren't important in terms of the content of the conversation. Basically, participants were inattentive to those changes occurring. Now, the reason for attention, in a nutshell, is we can think about it in terms of putting the world together and establishing some sort of coherence. We have to use attention to establish when changes occur, when important information is being relayed. Attention is the mechanism through which we establish and grow in the world. And the concept that we use to refer to that is called binding. And this is the idea of taking all of the little physical characteristics of an object, all of the meaning that we associate with an object, and binding it together to essentially create our perception of that object. And in this example, so this picture, I use this in the cognitive neuroscience chapter. This is an example of all of the little characteristics that are associated with this rolling ball, the movement, the location, the color, the shape, all of these different things are things that we pay attention to. They're all components to our concept of this ball. And in order to actually put this ball together, we have to attend to each one of those characteristics. Now, in attending to those characteristics, or as Treisman put it, features, we need to think about how our attention actually allocates resources. Now, what our attention does, according to the FIT model, is basically it goes through a pre-attentive stage, a focused attention stage, and then it establishes perception. And the idea of the pre-attentive stage is to analyze features. So the features of motion, depth, color, shape, location, those things like that, move from the pre-attentive stage to the focused attention stage. And this is the point at which we actually apply meaning to that object. We combine all the features together and we establish what those things are. And the pre-attentive stage is automatic. There's no effort. This is something that occurs and requires very, 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 very small amounts of cognitive resources. We're unaware of this process, and it's also a kind of gestalt idea of looking at the component features of an object. And Treisman and Schmidt asked participants to report a combination of features from different stimuli. And basically, there were a lot of conjunctions, so combinations of info that occurred because there was no location or grounding associated with these objects. So this is an example of one of the stimuli. Because they're ambiguous, because they're not situated in any sort of practical way, participants tended to remember the component features and where those features lay, but they also ended up combining information. And because of this is a demonstration basically that rather than looking at all the simplistic components of the stimulus, participants by default bound those components together. They would also ignore or basically be inattentive to the numbers because they aren't as similar to the shapes and colors in the center of the field. They can, however, correctly pair shapes and colors. One important thing we can do in looking at attention is establish how different disorders might influence our ability to attend to objects. And a syndrome called Balint's syndrome gives us an interesting perspective regarding the fit theory. And basically, people who have Balint's syndrome can't focus attention on individualized objects. Imagine when you get kind of a unfocused look in your eyes, or you're spaced out is kind of a colloquial term that people might refer to it. This is kind of a permanent thing for people with Balint's syndrome. And they have a high number of illusory conjunctions. Essentially, all of the objects in their field of vision, all of the stimuli that they're receiving, they're much more likely to pair them together and mismatch different features of different objects. It's meaning that this is mostly bottom-up processing that's occurring. All of the little features are being analyzed and then put together and bound together while we attend to a stimulus. Now, top-down processing influences processing when participants are told what they would see, and this is basically an attempt to impose meaning on those feature-based bottom-up processing components that are being bound together. And basically, we need both this bottom-up and top-down processing in order to accurately perceive objects. Okay, so that is attention in a nutshell, or at least the chapter of attention. The quiz has been posted. Discussion has been up since Tuesday. So regarding next week's exam, I've posted a kind of an exam study guide, and I'm going to just copy and paste the quizzes. For some reason, I can't get them to reopen to basically, so you can go back through them. I'm going to see if I can't figure that out, but if I can't, I'll just post the questions anyway. For the first exam, it's going to be primarily multiple choice with 8 essay questions. You'll have until Thursday at midnight to complete the exam, and you'll need to use the Respondus Lockdown browser. If you had issues using the Respondus Lockdown browser, you need to let me know so that we can figure out and probably schedule a time that you can take that exam in a computer lab, or we can figure out what best way we can get that going for you. So that's attention. Thank you for your time. And I'll see you on Tuesday when I post the exam. I'll give a little kind of a summary to answer questions and maybe head those off at the pass. And hope that everyone has a great weekend.